Hello, and welcome to GP Podcast. You know, there's a silent revolution brewing in the world of artificial intelligence. While we've all been absolutely captivated by chatbots that can write poetry or, pass medical exams, a completely different kind of AI is quietly taking shape, and it's one that might not need to speak in order to think.
So let's just dive right into that. Let's ask a really profound question. What if the path to true artificial intelligence, to machines that genuinely understand our world, has almost nothing to do with language? What if talking is just a useful skill, but it's not the core of intelligence itself? That's the provocative idea right at the heart of what we're talking about today.
And look, this isn't just some philosophical debate. The spark for all of this is a new research paper coming out of Meta's FAIR Lab, which is led by the absolute legend in AI Yann LeCun. In this paper, it's introducing a model that isn't just an incremental update. Now, this is a fundamental challenge to the way we've been building AI for years.
It's called V-JEPA. That's short for Video Joint Embedding Predictive Architecture. But let's break that down. In simple terms, it's an AI that learns by watching. It just observes the world, in this case through video, and it builds an internal model of how things work. It learns to predict what's going to happen next, not by writing a description, but by actually understanding the underlying reality. And this quote right here, it just perfectly captures the whole philosophy driving this research. Yann LeCun has been arguing for years that we are way too focused on language. He believes real intelligence is all about building a predictive model of the world. Language? That's just one way to output that understanding. It's not the understanding itself. And V-JEPA, well, it's the living embodiment of that exact idea. Now, to really get why V-JEPA is such a big deal, we first need to understand how today's big-shot AI models, like ChatGPT, actually think. They operate through this process of generating language, one tiny piece at a time. What's so wild about this is just how linear it is. The model gets a prompt, and then it doesn't plan out its full answer. Nope. It just predicts the most statistically likely first word or token. Then, based on that first token, it predicts the next one, and on, just stringing the response together piece by piece. It's literally building its thought as it goes, which, as you can imagine, is incredibly slow and burns a ton of computational power.
Okay. Now let's look at the challenger, V-JEPA, which takes a completely different path. V-JEPA is what we call non-generative. It doesn't need to speak to think. It operates directly in the realm of meaning, what researchers call an abstract semantic space. You can kind of think of it as a space of pure concepts, where the idea of a cup exists without needing the letters C-U-P. This slide is so important because it lays out the two competing philosophies side by side. On the left, you've got the generative way, where the whole reasoning process is tied up in producing text. But on the right, you have V-JEPA, which reasons in this abstract space of pure meaning. Language becomes an optional extra, only used if you ask for it. So here's the key takeaway. One thinks by talking, the other thinks and then talks. Big difference.
To make this a little less, abstract, the researchers themselves use this fantastic analogy that really makes the difference crystal clear. So imagine you're watching a scene unfold. You've got two ways of describing it. One is like a simple security camera, and the other is like a thoughtful human observer.
A basic AI vision model? It's that security camera, just analyzing each frame in total isolation and shouting out labels. It sees bottle, then hand, then bottle again. It's just reacting. V-JEPA, on the other hand, is the human observer. It watches the whole continuous flow of events, builds this internal, evolving understanding, and only reaches a conclusion when it's confident. It doesn't just see a hand and a bottle. It understands the action of picking up the canister. It gets context. It gets time.
Okay, so the philosophy is interesting, for sure. But does it actually work any better? Well, let's look at the data, because this is where the challenger really starts to land some heavy blows on the reigning champ.
So this table shows how well these models do on a video classification task. Basically, it's a test of how well the AI understands what's happening in a video. As you can see, older but still well-known models like CLIP are down around a score of 55. V-JEPA, even in its most basic form, already outperforms them. But then look at the supervised version. That is a massive leap forward. It's just flat out better at understanding video.
And it's not just about the final score, it's about the speed. This chart shows the learning curve. While those traditional models are slowly grinding their way up, V-JEPA's performance just shoots up. It reaches a really high level of comprehension with way less training data. This is some powerful evidence for that core idea. Learning to predict abstract meaning
is just a much more efficient way to understand the world than trying to predict the next word. And here's the real kicker. V-JEPA achieves all of this while being dramatically smaller. It uses roughly half the trainable parameters of its competitors. Now, trainable parameters are kind of like the knobs and dials an AI uses to learn. The more you have, the more complex and power-hungry the model is. So just think about that. Better results, faster learning, and half the size. That's a revolutionary claim.
So let's just pull back for a second and look at the bigger picture here. This isn't just about building a better video analysis tool. This could be a fundamentally new direction for AI, a direction focused on creating agents that actually understand our world, not just describe it.
So why does this matter so much? Well, because an AI that truly understands cause and effect and time and context, that's exactly what we need for the next generation of technology. For robotics, this means a machine that doesn't just follow a script, but can genuinely plan and react to new situations. For things like self-driving cars, it's a difference between just reacting to pixels and truly understanding the flow of traffic. And for all of us, it promises a much more efficient future for AI.
A researcher on the team, Sonia Joseph, put it absolutely perfectly. She said, "To understand traffic, we don't need to simulate every single atom with quantum physics. We have models of traffic flow. We find the right level of abstraction." And that's exactly what JEPA is doing. It's not trying to predict every single pixel in the next frame of a video. It's learning the abstract principles of what's actually happening. It's optimized abstraction.
Now, critics have pointed out that, hey, the model isn't always 100% accurate in its predictions yet. And you know what? That's true. But focusing on that kind of misses the bigger point. Perfect accuracy today isn't the breakthrough. The revolutionary part is the approach. This is a deliberate step away from just building better chatbots and a huge step towards an AI that can genuinely understand and interact with the physical world.
And that leaves us with the final and most critical question. Is this the moment we start moving beyond an AI that has mastered language to one that is finally beginning to understand reality? Is the future of intelligence silent? It's a fascinating thought to end on.
And that's our look at V-JEPA. If you liked this explainer, please subscribe, leave a like, and share it. And definitely comment below on what you found most interesting. Thanks for joining us on GP Podcast.